I recently learned that Python lets you deal with complex numbers, and as I was playing around with this, I decided that I wanted to plot the Mandelbrot set, this nice figure right here, just as a fun exercise, and also to learn a bit more about what it actually is, this thing, the Mandelbrot set. And I ended up making this animation um, right here. And I thought it was kind of neat, and I decided that I want to show you how to make something like this. So what I did for starters is I went to the Wikipedia page, of course. What's the definition? What is actually the Mandelbrot set? Well, it's defined for the complex plane, so you have two coordinates, each point, and you look at the criteria, whether the function for a given point in the plane, C, if this equation diverges, then it does not belong to the Mandelbrot set, in which this z is starts at 0, and then you feed the output of the function back into the function again, and you kind of reapply the same function over and over and over. And if the number just blows up, it does not belong to the Mandelbrot set. So all these black points you see here, those belong to the set, and everything outside does not. And then you have the borders here, which are colored by some scheme, probably based on the number of iterations or something. I'm not completely sure. Anyway, we start out by going to, I'm using Jupyter Notebooks. So you have to use the keyword complex, and here you can input the real number and the imaginary part. So this is going to have the representation like you see here. So that's all neat and good. Now we need to make this function right here. That's z squared plus c. So we have to make that. Define, just call it f. It takes two inputs, c and z. And that was return z squared plus c. Okay, so if I just make some number c1 equals complex 1, 2, f of c, c1, and so like in the definition, z starts at 0 when you count. So I'm just going to call z0 equals 0. So I'm going to feed that in, and that gives me something. And so the idea is that you call this like your first result. I can call that, well, call that z0. So this will be like c1 equals this, and then z2 would equal f of c1 z1, etc. And you just kind of continue to reapply this thing. And we can kind of like manually see what happens with this thing. So z3, just to get like an intuition on the thing. Let's see here. Yeah, it looks like this thing is going to diverge quite quickly. I can pass it once a final time. And yeah, I mean, there's no doubt that this thing is just going to blow up. So this point, 1, 2, will not belong in the Mandelbrot set. So I need a way to determine whether it will do that. Well, because we're dealing with Python, and maybe there are some advanced mathematical ways to determine whether something diverges or does not, but I'm kind of going to use the naive approach and just set some arbitrary threshold and do a number of iterations and see whether or not it has reached that threshold after a number of iterations. And I just chose some numbers quite randomly, and it seemed to work. I just set the upper limit to 20,000. And when I say diverge, I'm referring to the absolute value of this number. So you cannot say, just look at the real part or just at the imaginary part. You have to look at the absolute value of the function, and you can use this abs function in Python. That's nice. So I'm going to make a new function, and I'm going to call it diverge. So I'm going to return I guess a 1 or a 0 based on whether or not it diverges. So I want to again intake the point C and the Z, which is by default it's 0. I need a number of iterations, an iter. I'm gonna just set that to 20. and the boundary, I'm gonna call it just gonna call it B and equals 20,000. So now I need to feed this function into itself this number of times. I'm gonna make a loop for I n and iter. And this is nice with Python, that you can like override this your input arguments. So I can just say z equals f of c z, and doing this many times. And at each time I'm gonna check if the absolute value of z is greater than our boundary. Well, that means that it does diverge. So then I'm going to return 1 as meaning diverging. And otherwise, if the loop finishes and it doesn't reach this, then I'm just going to return 0. And I think that is sufficient. Let me just test it to see if I forgot something. So, for example, this point, C1, where I see an error, integer is not. Of course, I need to have for I in range an iter. Yeah, and there we go. This has 1, and like I said, that does mean that it does not, that it does in fact diverge, and that's also what we would expect from the results up here. I could choose a point that I know should belong. I think 0, 0 definitely should belong, and that's also kind of obvious from the formula, that if you just start with 0, then you're just gonna have 0 all the way. But we can test it once again, just to see that the code does as expected. So diverge of complex 0, 0, that's 0. Okay, good, it does not diverge. So next up, we should be ready to actually plot this thing. So here comes kind of the boring part, in which we have to, well, first of all, we should import from matplotlib, import pyplot as plt, and we are going to, well, first just define our frame. So I think it ranges from about, well, we have to say like xmin and xmax equals -2 and I think 1 approximately, and ymin, ymax equals -1 and 1 respectively. So we're going to use the numpy function, so let's do that too. Import numpy smp, and we're going to use the mesh grid function. So the numpy mesh grid function returns two outputs. I'm going to show you in a moment what they do. So you call them by convention xx and yy. And we have to input two things. and we're going to use the numpy linspace function. So xmin, xmax, and then we need to define a resolution. I'm just gonna make a number for that. Resolution equals, say, 200. That means 200 pixels wide, or 200 points between the minimum and maximum, evenly spaced. So I'm going to do this for the x's, and then similarly for the y's. So if we display, actually I'm going to change the print options. You can do this numpy print, let me see. I think well, maybe it's set print options. I think that is the function. Yes. And then you can define the precision. I'm going to use 3. Actually 2, that's fine. 2 is fine. Okay. So the axis is just a matrix of the shape of the whole grid, and it just shows the x coordinate, and the yy shows all the y coordinates, and both have the same shape of 200 times 200. So the next step, we need to pair up all the x's and the y's so we get a list of all the points. And the standard way to do this is using the numpy.c underscore function. And then we have to ravel these the yy and the xx. And I'm going to show you that in a minute. Let me see, I think I did something. I need to feed in. Oh yeah, I see what I did wrong. It's not a callable function. I have to index it using the same thing. And this, like you see, it just pairs up all the possible, or all the coordinates. So you get for the first point, -2 and -1, and the next one, 1 minus 1.98 and -1. So these are paired up, and then this one, and then this one, etc. So we can just we have to give this a name. We just can call it, so all our points. Let's call it points. Why not? Points.shape. Okay, so now we can basically, for each of the points, we can calculate whether or not it diverges. So let's go ahead and do that. I think I'm going to use a list comprehension for this. So diverge. Actually, I want to input these numbers like that. So diverge C for C in points. But I see that I need to explicitly input this as a complex number. I think I'm just going to do that for, let me see, I'm going to get some error here because we haven't passed it in as a complex number. I just want to edit this function here, say C. You can say that C can be like of arbitrary size like this. C equals complex of the C's. I don't need a star here. Like this, I think should be, make it good. Yeah, there we go. So, well, this isn't too informative, but let's see. This, these are all the points. So Mandelbrot equals this. And now we just need to reshape this thing because now it's a one-dimensional vector, and we can plot it. So the shape was, I think we can simply do Mandelbrot.reshape 200 well, res by res. Let's see if that works. Oh, now it's a list, of course, because it's a list comprehension. Let's turn it into a NumPy array first. Let's see here. NumPy array Mandelbrot dot reshape 200 200. Okay, I think that's good. Let's just try to run an imshow on that. So plt.imshow Mandelbrot. Yeah, there you go. So now we have the basic structure, but actually I think I might use another function, because this kind of squishes and distorts the dimensions. I think contour F should work. Yeah, I prefer that. And well, let's see, make this a bit more general. Res. So now we can adjust this. We'll make a low resolution. Let's make it very low just to show the point. Here you see, super low resolution. And we can have higher resolution if you want to, 500. So of course it's going to take longer time, proportional to the resolution. But about making this animation that I showed you, well, I can just show you that if you change this exponent, this is quadratic, that's Mandelbrot, but you have multi-brot, so you can have any number in here. So if z equals 3, well, now I'm making it's a bit too high, the resolution. I can have it at 150 just to show the point. But now you see basically that the whole thing split, and you just added another one, so they're kind of facing each other. If you add 4, you see you get another one, and this kind of will just continue infinitely. So what we can do is that we can basically write a loop which does all this, and we can save the image at each point, and then we can finally make a GIF out of it. So let's make a function. Just move all this code into a single function. Def plot Mandelbrot. I'm just going to copy and paste everything so far. Actually, I think I want to, yeah, we can do this. Call it K, like that. And this is what we input. So then we can change it as we run this code. Well, I don't need to redefine this, I don't think. This is all fine. Suppose, actually, I don't think I need to copy paste this. This has already been defined. I need to do this though. And this. Let's just see if this does the trick now. Plot Mandelbrot, yeah, 2. Okay, plot Mandelbrot 6. Yeah, no, wait. Something's wrong here. Let me see, what did I do wrong? Scene points. to see because this is still stuck at the old definition, which I set to 4 up there. Okay, so I need to redefine this apparently. Let's see now. Well, I need to input something here. Of course, the K. Like that. Okay, now it does what it's supposed to do. And we can also adjust these borders. It looks like it's should shift it a bit to the right and increase the height a bit. So it was first from -2, well, let's say -1. Should be fine, -1 to 1. And so what about 0.2? Well, now it's kind of skewed, so let's make them both this little extra. So I'm gonna reduce the resolution because right now I don't care too much. Okay, that's fine. So, okay, I'm going to yeah, and also the thing I forgot to say that you can input any number. It doesn't have to be whole numbers, so I can have like 1.1 and see what happens. Okay, that's maybe not the best example. 2.1 and 2.2, and it's very gradual. So what I'm gonna do is I'm gonna make we call it case equals numpy linspace from, I guess, from 1 to 8, for example. And I want, how many frames do I want? Well, maybe 100. Oops. And so I say for k in case, no, excuse me, for k in case, that's fine. Do what? Well, actually I can just, in this function, I can have plt.savefig. Just gonna save the figure. I'm gonna call it something like, I'm gonna use an f string. I'm gonna Mandelbrot underscore and then k.png. And just check that this works. Yeah, now I have this figure right here. As you can see, that's all good. So now, I'm just gonna do this, run this for all the case. Plot Mandelbrot. Okay, this is gonna take a little bit of time to run. And as it is doing that, I think it's image.io, the library for like gluing together these JPEGs. I'm just gonna go ahead and see image.io make GIF. Okay, so I just put all the stuff into a single folder. I guess I can slightly edit that. So because I have a simple rule for the file names, so file names equals, well, they're all called Mandelbrot underscore k for k and ks. So, and then .png. It looks like 100 was maybe slightly a bit much, but that's fine. So let's see. You can say for file name then in fns. Yeah. File path is just the file name. Images, so images should be just a empty list. Just gonna give it another name, output.gif. And I'm gonna get back to you once this thing is done running. All right, so it finished running. So, and it plotted the last image. So let's just see if the code works. Oh, I got import image IO, of course. Import image IO. Let's see now. All right, so let's have a look at it. I called it, what do I call it? Output. Output.gif. And there you go. That's a pretty cool animation. And of course you can increase the resolution as much as you want, and you know, depending on how nice your animation is. And you can also play around with like zooming into these details, which here are kind of I have ignored, but of course that's the like one of the most fun things with fractals is that you can do the zoom in forever and ever, and you're just going to keep seeing new detail. But yeah, I mean, there's a lot of stuff to play around with in Python, using imaginary or complex numbers. And there's probably more efficient ways to implement this, but at least it was a fun exercise to kind of explore the Mandelbrot set.